So you're changing the 3 in front of theta on the first one to a 2. And then on the other one, it's going to be 4 theta instead of 3 in front of theta. So the number in front of theta is going to change. All right, so when you guys come in, you know to read. So it tells you to work on problem number 2, and I want you to grab cosine theta first. So the original cosine graph. So even if you don't like radians, which is fine, you could really just figure out all the conversions from degrees to radians and vice versa and do it that way. But you should know the shape of cosine from last unit. So you're going to grab cosine theta, and then I'm going to call on people, and you got to tell me where to put my points. So we grabbed y equals cosine theta first, easy peasy. Then we grabbed 2 cosine theta. And again, if you don't need to do the red one, like you can grab y equals 2 cosine theta first, because you know that's positive 2 and negative 2, then be my guest. So then for the next piece, we have to change the period. So already picked on you. All right, so Michael, what do I do to find the period? So it's going to be 2 pi all over 4. So I know a lot of you are tempted to use 360, but we're no longer using degrees. Everything's radians now. So you're going to do 2 pi over 4. Can I simplify that? To what? To pi over 2. So that means instead of taking from 0 to 2 pi, this is only going to take me from 0 to pi over 2. So did I stretch out or did I push it in? So push it in. So it's going to shrink horizontally is what we would call it. But so what's nice is that the starting point never changes. So this particular point stays, but my last point is now not going to end at 2 pi. It's going to end where? It's going to end at pi over 2. Okay, so the trick is whatever number you divide by to get your period is the same number you can divide by to figure out where 1, 2, and 3 move. So you need to move those 3 other points. So that's why Mr. Kim, when he did this with you, he said think about it in terms of quarters. Because dividing by 4 is a quarter, if you don't know. Okay, so let's do something that I know is easiest. If I take pi and divide it by 4, what do I get? We just get pi over 4. So that means instead of having a point at pi and negative 2, you're going to move it to pi over 4 and negative 2. Okay, so before I can get to my minimum from my max, I have to touch the x-axis, right? My zeros. So if this is at pi over 4 and this is at 0, is it possible that I'm going to have my next point be way over here or over here? No, that 0 has to be halfway in between. So I'm not going to measure, and neither is Mr. Kim, and be like, oh, you know what? That doesn't look like the right number. So you're going to put a point halfway in between pi over 4 and another point halfway in between pi over 4 and pi over 2. Yeah. Okay, so that's only one period, though. So we're going to go all the way out. But before we do that, I know you guys hate fractions, but a fraction's more realistic than a whole number. Okay, so we do. But we're just doing the period change because that's the hard part. You guys can move up and down. So to get that pi moved to pi over 4, I divided by 4. We're going to do the same thing for pi over 2 just so I can prove to you where that point is. We already drew it, but I just want to show you why. If I have pi over 2 divided by 4, does that look nice? No. So I'm going to rewrite it as pi over 2 divided by 4. What can I put underneath the 4 to make it a fraction? A 1. So I know Mr. Kim did this with you guys. If I'm dividing two fractions, I change division to what? To multiplication. So it's going to be pi over 2 times, what do I do with the second person? We flip it. And so that's going to tell me pi times 1 is pi, and 2 times 4 is 8. So this point that was at pi over 2 moves to pi over 8. So I know you guys hate the fact that it's pi over something, which is totally understandable. More than one period. So what's my period again? How often is this going to repeat? Pi over 2. So this point is at pi over 2. What's pi over 2 plus pi over 2? So pi over 2 plus pi over 2. What's pi plus pi?
2 pi.
2 pi over, when you add fractions, do you change the bottom? No, so it's going to be 2 pi over 2, which is just pi. So that means the next time you have this point is at pi. Bless you. Bless you. All right, so if you look at the scale, every 2 lines is pi over 2. So when is the next time that this dot is going to occur if I have to add pi over 2 again? It's going to be at 3 pi over 2. And it's going to happen again at what? 2 pi. So if once you notice, like, oh, 2 lines, there it is. So then 2 lines, 2 lines. Because it's scaled nicely for you. So then we're going to do the same thing with that bottom person. Okay, so, and then again, if you don't like radians, don't use them then. So what's pi over 4 in degrees? Anybody know? How much is pi over 4 in degrees? 45. So how much is pi over 2 in degrees? It's 90. So I would know pi over 2 off the top of your head, and 2 pi, well, I know you guys know 2 pi. So the more you know off the top of your head, if you don't like radians, then just don't use it. You can use degrees. So since I know that this is 45, and we just said pi over 2 was 90, 45 plus 90 is 135, which is the same as 3 pi over 4. So again, obviously I've done this longer, so I have all of this committed to memory. I don't need to convert. So pi over 4 plus pi over 2 is going to give you this person. Or again, you can convert all these to degrees and then do it that way, whatever floats your boat. What's the denominator of both of these where our minimums are? Well, the y is -2, but what's the denominator of the radian? So this is what? 4. This one's a 4. So the next one's probably at a one that has a 4, and then another one at 4. If you add 90 to pi over 4, it's going to be 3 pi over 4, add it again, 5 pi over 4, blah, blah. So what's the only points we haven't moved? So I moved the max. What are these called? The minimums. What do we call the ones that are on the line? We call them on the midline, or you can say that they're zeros. So where was the first point? It was at pi over 8. And it's halfway in between my max and my min. And the next one is halfway in between the min and the max. So this next point has to be halfway. You don't have to calculate it. Don't calculate them unless you just want to practice. I'm not going to calculate all those. So you're going to put it halfway, 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 all the way out. And then play connect the dots. So once you figure out the pattern, you don't have to keep doing calculations. Like if you figure out like, oh, I'm just moving things 2 lines over, then do it that way. But you have to first know what cosine looks like. So if you don't know that cosine goes max, midline, 0, midline, max, midline, minimum, then there's nothing you could do to figure out the pattern. Okay, so what's the final step? Somebody said it earlier. So there's one more number, right? So that's the vertical translation. Which way do I move? Down 1. So I know you guys don't need my help with that. So every single point moves down how many? 1. So change 3 minutes on number 3 to 8 minutes, and then 6 minutes on number 4 to 8 minutes. So we're going to do problem number 3. Yes. So it says write a function, and instead of sine, can you cross out sine and make a cosine? So we're going to write a cosine function for the following. So we're back to your old friend, that's your Ferris wheel, right? So it says an amusement park ride is on a circular track with a diameter of 50. So you're going to write that D equals 50. So your diameter is 50 feet. The passengers will board at the highest point. And then the center of the ride is 45 feet above the ground. And again, it's going to rotate once every 8 minutes. Okay, so what I want you to do first with your partner is to just do that first sentence, which is find the highest and the lowest point of your circle. So what I would recommend doing is drawing a circle and labeling it first. Okay, so go ahead and do that with your part of my circle. So the highest part is 70 feet. And then what did you get for the lowest part? It's 20. So the trick to this problem is that you have to figure out what the radius is. So if the diameter is 50, my radius is 25. So that means from my center to to the top is 25. From the center to the bottom is also 20. From the center to the bottom of my circle is 25, but from the center to the ground is 45. So this piece that I'm going to highlight in orange, that distance is 45. So if I know from the center to the bottom of my circle is 25, but from the center to the ground is 45, what am I going to do to figure out what the small piece underneath is with the 45 and the 25? We would subtract it. So 45 minus 25 is 20. So that's how the lowest point is 20. So if you forgot how to do that, all the adding and subtracting, which should be the easy piece, you should go back and look at 6.1 and 6.2 and your 6.1 through 6.3 quiz. That would actually help you. All right, so then on that sound wave task, you guys found the midline. So if the top of the Ferris wheel or whatever it is 70 and the bottom is 20, I want to know where the middle is. You can, yeah. So what's in the middle of 70 and 20? It's 35. 45. So it is 45. Okay, so the midline is 45. You just average them. So if you did 70 plus 20, which is 90, and then divide by 2. Oh, and it does tell you in the directions, right, that from the center to the ground is 45. So we already knew that this was the middle. All right, so now, how long does it take me to complete a full circle around? 8 minutes. So how many radians is all the way around?
360 or 2 pi.
So it'll be 2 pi. So I go 2 pi in how many minutes? 8. So what do I do with 2 pi and 8? Divide it, and that's going to tell me how many radians I go per minute. So what can I simplify both 2 and 8 by?
Pi over 4.
Simplify by 2, and we get that it's pi over 4. So I rotate pi over 4, which is the same as 45 degrees every minute. It's pi over 4, so it's 45 degrees. Okay, do I want to start your table next or your equation next? Let's do your equation. Okay, so it tells you you're going to use H equals W plus Z cosine TX. So on the test from last unit, when we changed the letters, a lot of you were freaking out. So we decided to throw that on this one so that you don't freak out. So I have H, probably stands for height or something, right? W plus, thank you, Z cosine TX. So we have to figure out what W, Z, and T are. So what number is normally, or what value is normally right next to cosine and sine? The amplitude. So we need the amplitude. This number always helps us find our period. What about numbers in front with a plus sign? It's our vertical shift or vertical translation. So it doesn't matter what letter it is. You look at the placement of the letter. So different teachers use different letters. So I know like me and Mrs. Luda use the same letters, but Mrs. Yang used different letters. So the letters actually are irrelevant. Okay, so where is the midline for cosine normally? So you can look back at number 2. Where was the midline? It was at 0, right? But in this one, where's our midline? 45. So did we move up or down? We moved up. So that means we already know that W is 45. Because the only way you're going to move up is with a vertical translation. So we just figured out what W is just based off of what we already knew. So I'm going to erase this because I need some space. All right, so now we got to figure out what Z and what T are. So the more you remember about what numbers we used last time, you can shorten this process. But if you don't remember, then we'll just have to do it from scratch. Okay, so we start here, which is at the top of our graph. So if I haven't moved yet, how many minutes have passed? 0 minutes. Can we all agree that no time's passed because I haven't moved? Okay, so I'm going to do this off to the side. So if I plug in a 0 for X, does it really matter what number T is? No. Why not? It will still be 0, right? Anything times 0 is 0. So we have 45 plus whatever the heck Z is, cosine of 0. This is why you have to know your unit circle, like off the top of your head. What's the cosine of 0? It's 1. So if you know your unit circle, the cosine of 0 is 1. So if you don't know your unit circle, make sure you make a copy of the paper. I have extra copies. Just keep redoing it till you know it. So this is 1. So I have 45 plus Z times 1. Do I really need the times 1? No. I'm going to leave it there, but you don't need it. How high off the ground is this guy? 70. It's 70. And how much time has passed if I'm right here? 0. So it takes me 8 pi to come back around. But if I just started, Has any time passed? No. So I already know at 0 seconds I'm where?
You're still at the same spot. 70.
I'm at 70. So that means the answer to whatever the heck this is 70. So 45 plus what gives me 70? It's 25. But didn't we already have this number before? It was what? The radius. So again, if you already know that the radius is the number in front every single time for this type of problem, you could have skipped that whole thing that I just did. But if you don't remember, you have to do it by scratch. So it's 25 cosine of, we have to figure out what t is. So we're trying to figure out where you are every single minute. How many radians do I rotate per minute? Pi over 4. So this is cosine pi over 4 x. And same thing as last time. If you remembered, the number that you got when you did 360 divided by however many degrees you rotated in minutes, that number was always by the variable. Same thing here. So if you remember, save yourself time. If you don't, you got extra steps. This is how it is. All right, so why do you think there's a graph there? To graph it. So Mr. Kim taught you guys how to do this using a table. So we're going to make a table. So we're going to plug in x values and find our y values. So x is time. So if 0 minutes have passed, where do we say we were? We were at the top, right? So how high was the top? 70. And then after 8 minutes, I'm back at 70. Okay, so I know I start at the top. How long or how many minutes would it take me to get to the bottom? So if it takes me 8 minutes to go all the way, it'll be 4 seconds to get to the bottom. How do we know it's 4? It's 8 divided by 2 or in half, which is 4. So if you're looking at your circle, to go from top to bottom, that's half a circle. So we're going to put 4 seconds, and we know how high off the ground is the bottom. It was 20. The bottom of your circle was 20. Yeah, after 4 minutes, whatever. All right. Figure out how many seconds it's going to take me to go from the top to the middle. So I'm going to redraw my circle. We start here. How many minutes does it take me to get to that side? So we already know to get from top to bottom, it took me 4 minutes because that was half a circle. So it'll be half of 4, which would be 2. So after 2 minutes, I get to the middle. And how high was the middle? It was what? Was it 25? The center is 45. So what am I counting by? 0, 2, 4. What would the next number be? 6. So after 6 seconds, am I going to be at 70, 45, or 20? It's going to be 45. So did you have to plug into this at all?
No.
No, we didn't have to plug in. So if you know how to do it with a drawing, you don't have to plug in. But I'll just show you that you could have plugged in one time. Let's do, we're going to plug in 2. All right, so we're going to verify the answer for 2 minutes. If I have pi over 4 times 2, what can I simplify both of these by? By 2. So you can multiply across, but you know that that's a way longer method, right? So that becomes a 2. What's the cosine of pi over 2?
9.
So that's 90 degrees, and the cosine of 90 degrees is 0. So again, got to know your unit circle. So if this is 0, what's 25 times 0? 0 and 0 plus 45? 45. Yep. I'll finish up and then, yeah. All right, so make sure, please, that you know you're in a circle. All right, so take out your pink paper. I will take a question from your pink paper before I leave for my game.